All right. Sorry, guys, I'm not here today. I'm at a doctor's appointment. I could roll in at any moment in time. So if you're an absent person, this is good for you. If you're somebody in fifth period, I think this is where we got to yesterday. The middle of the page, section 4.2, talking about the triangle sum theorem and using this theorem to prove a bunch of mini corollaries. So we should have gotten through the equiangular corollary, the right triangle corollary. I don't think we got through the next one, which is this situation where you have two different triangles you're comparing. It's called the third angles corollary. Now, if you can't hear me very well, sorry about that. I don't have a microphone today, so I'm kind of working just from the speaker on the computer. So I'll try to talk loud enough you can hear me. So this little corollary, again, it's like a mini theorem, says, and it's a pretty obvious one, says that if two angles of a triangle, in other words, if I have x and y on this triangle, are congruent to two angles in another triangle. So these are x and y, and these are also x and y. There's something you can conclude about, as it says here, the third angles. Uh-oh, something happened here. Hold on a second. No, I don't want to update my Java, Oracle, whatever. Alright, there it is. If these two angles are congruent to these two angles, you can make an obvious conclusion, maybe an obvious conclusion about the third angles. Well, this angle, Z, should be congruent to that other angle, W. And if I was in class, I'd say, well, why would that be obvious? And most of you would say, well, because these add up to 180, and these add up to 180, and if these two pieces are the same as these two pieces, well, whatever's left over has to be the same. We just got to get that into a proof. So most of you would say, well, these add up to 180. And there's your theorem. So x plus y plus z adds up to 180. And at the same time, you'd have to set up another equation, and you have to slow down your thinking maybe to slowly prove this thing and piece by piece explain it. These also add up to 180. And I'd ask you why. And you look at the top of your page and you go, hey, what's that theorem called where the angles add up to 180? Oh, it's called the triangle sum theorem. And then, the colors do mean something on here. I've got all this blue stuff is equal to 180. And I've got this blue stuff is equal to 180. And I'd ask you the question, what can I do with this blue stuff? Or what would I set this blue stuff equal to? And somebody in class would raise their hand and go, oh, set it equal to the other blue stuff. And I'd say, what's that called? What's it called when you set, two things are equal to the same thing, so you set them equal to each other? And somebody would probably say transitive. Hopefully they'd say transitive. There's another name for it too. And you might be thinking substitution. Technically it's substitution. And the whole idea what I'm trying to prove right here is I'm trying to prove that the third angles, Z and W, are congruent. So I'm trying to get Z and W in an equation by themselves. Well, if you look, you can see why I did it. What can I get rid of on both sides? I can get rid of x, and I can get rid of y. And I would say, well, if I got rid of them, mathematically, what am I doing to get rid of them? And somebody would raise their hand, and I'd call on, oh, hey, Graham, what'd you get? Oh, Graham said subtraction. So there's your quick little three-step proof of this third angle corollary. When you're ready, flip the page over on the back. Got something called the exterior angle theorem. I want to go through and prove that. This is the one that we did in class. It took a few minutes for you to really figure out the pattern in these numbers on here. And on your paper, you don't have this little extension. You've got to extend aside, just like we did in class yesterday, extend aside so that you create an angle that's outside the circle, or that's adjacent to an interior angle. And of course, we know if it's adjacent to an interior angle, we're going to call it an exterior angle. So let's read through the theorem as we put it all together. An exterior angle of a triangle, that's number 4, is blank in measure to the blank of the other angles on here. This is what we came up with in class the other day. This angle does relate to 3, but we wanted to relate to the ones that are far away from it. And if you remember from yesterday, we called those the remote interiors. If we added these up, or if we found their sum, whatever these add up to, it's equal to angle 4. You have to use this quite a bit on the homework. And again, by remote, I mean the one that's not adjacent to it, the ones that are far away from the exterior angle. So if you add 2 and 1 together, the remote interior angles together, you get whatever 4 is. So this is the theorem in terms of the picture. Angle 1 plus angle 2 equals angle 4. We want to go and prove that now. And the proof of it's actually a pretty easy proof. We want to show that these two equal that one. And so I'd start with asking you the question, what do you know about these 3 angles? And of course, you know from quite a bit of what work we did yesterday, those add up to 180. And I'd say, why? Somebody would say, oh, that's the triangle sum theorem. I'd maybe ask the question, are there any other angles here that add up to 180? You look at the drawing, you can see there are other pairs of angles that add up to 180. Somebody might say, oh yeah, 4 and 3 add up to 180. And here's where the proof really makes a lot of sense, I think. Look at how I've written these. 180 is lined up, 3 is lined up, and 4 is lined up with 1 and 2. So it's kind of obvious, like if this was 100, angle 3 was 100, this sum would have to be 80, and this would have to be 80. So it's sort of obvious they'd be equal to each other. We're going to be able to show that mathematically now and prove it mathematically. So I have the blue stuff equal to 180. I have the red stuff equal to 180. I'm going to take that blue stuff and set it equal to, drum roll, the red stuff. Kind of like the last proof we did in a lot of ways. And then you'll notice these equations are almost ready to get me back to what I'm trying to prove over here. I want to have 1 and 2 on one side and 4 on the other. I want to have 1 and 2 on one side and just 4 on the other. What do I have to get rid of? Well, you can see what I got rid of. I got rid of 3 and I got rid of 3. And I'd say mathematically, how did I get rid of it? You subtracted it. So I've got triangle sum theorem. Some of you might want to say these are supplementary. Yeah, they're supplementary because they're adjacent, which makes them linear pairs. You could have the angle addition postulate here. Another possible reason on there. And then the transitive property is the final, third step on there. And the very last one, which I now realize you can't see on the screen, down here, sorry about that. We were subtracting angle 3 from both sides to get 1 plus 2 equals 4. So there it is, folks. I'm going to try to do a part 2 with the examples. So write these down. These are the 3 examples on the left-hand side of your page or in the middle of your page on the back. Write them down. Give them a try. On the next part, I'll put some solutions up. Thanks, guys.